Hello, ladies and gentlemen. Mr. Hescox getting back to you. This is Physical Science, Chapter 3. Chapter 3 is all about energy. So, what do you think of when you hear the word energy? Do you think of electricity? Do you think of the sun? Do you think of solar power? Do you think of turbines? Maybe you think of how you feel in the morning or something like that. We're going to move on and talk all the different types of energy today, and you'll have some review on the Google Sheet later. Energy has many forms. So there are many forms of energy, and we're going to cover those here soon. Some examples: food has what we call chemical energy in it. Inside your food, we have bonds, and those bonds give us energy. Energy is the ability to cause change. Here in this picture, you have the baseball player, which was back when McCutcheon played for the Pirates, changing the direction of this ball. That's an example of work. Oftentimes you'll hear energy as the ability to do work. Some of the forms of energy. First one is called mechanical. Mechanical energy is usually of some sort of mechanical machine, and it is a combination of kinetic and potential energies. So you have a brick that falls off of a roof. The brick is falling. It has kinetic energy as it falls, but because it's off the ground, it also has potential energy. If this is a roller coaster, and here's your cart on the roller coaster, mechanical energy means that it may be moving a little bit here, but it has more speed down here. But because it's above the ground, this height gives it the ability to fall due to gravity. And as it moves, it's going to go up and down. Every time it will lose some of the kinetic energy as it goes up because it's losing it due to gravity. Sound energy is the energy of vibration of particles from sound. Now, sound must travel through matter. You have a particle, and it vibrates into one particle, and then this particle vibrates into another. And you end up with a wave as the particles vibrate into each other. Chemical energy is the energy stored in food, chemical bonds of matter. So other types of chemical energy could easily be gasoline, could be firewood, it can be the battery that you use in your car. That's chemical energy. Thermal energy is often confused. Thermal energy is the total amount of energy in the movement of particles in matter. So thermal energy is not temperature. Temperature is the average. So you can't measure the speed of all of the particles in something. So, but we can take the average, and that average is what we call temperature. Temperatures differences cause things to move, heat. The faster a temperature moves, the faster those particles will bump into another particle, causing that to transfer the heat. Sort of like playing pool. When you hit the white cue ball really, really hard, it hits the other balls really, really hard, and they go off in a faster direction. The electromagnetic energy, as you see here, this is an X-ray. These are in electromagnetic waves. An electromagnetic wave is going to have, you have to picture this as a three-dimensional image here. So you have a wave coming out this way, which would actually be heading towards you at a straight angle. And then the other wave is going up and down. And that wave can actually travel through space. Sound cannot travel through space. But electromagnetic wave, the electric wave and the magnetic wave propel each other clear through space. So visible light, X-rays, radio waves. Now that could be radio waves like the radio in your car, or it can be radio waves like a CB radio or even a microwave. So here's some examples from TV radio waves to the car. Wi-Fi is technically a type of radio waves. Infrared light is actually a red emission from heat. The thermometers that we are using in school currently measure infrared light. We have visible light from red all the way to blue, ultraviolet light, which is actually bad for you. These are black lights. X-rays, which are more powerful. They penetrate your skin very, very easily, but get blocked by your bones. That's why the bones show up during an X-ray. And then the most dangerous of all are the gamma rays, and gamma rays are used in killing cancer, but they can also cause cancer at the same time. Nuclear energy. Nuclear energy is stored in the nuclei of atoms. Fission is when we take a really large atom like uranium and allow it to split. When it splits, it gives off heat. Heat boils water. Water becomes steam. And we can turn generators. Now, fusion brings into Einstein's law of E equals mc squared. Which is a really interesting one. E is energy, m is mass, and c is the speed of light. 300,000 kilometers per second. So when you square that, you're at a huge number. So just a little bit of mass that goes through that type of equation is going to give off a huge amount of energy. This E equals mc squared is very useful when we talk about the Big Bang Theory. Big Bang Theory basically says that everything in the universe was in one area. And then some sort of explosion of multitude of an energy is so great, basically caused all of the matter to come to existence. And it would have had to be such an enormous explosion that forced energy back into the form of matter. So a couple more parts to kinetic energy. Kinetic energy is energy of motion. Thermal energy is a type of kinetic energy. Sound energy is kinetic energy. Light is kinetic energy. But we can actually look at kinetic energy of objects. You have to look at the speed and the mass. So kinetic energy is 1/2 mass times velocity squared. You can have a high kinetic energy and have a high mass, like a train. Trains don't move really, really fast, but they have an enormous amount of kinetic energy because they have an enormous amount of mass. Or you can have a huge kinetic energy from a very high velocity, like a bullet. Bullets have very small masses, but they travel at 1,000 meters per second, which is a very high speed. So you can have that. I like to play golf. One of the things they tell you is if you want to get more distance out of your golf swing, you've got to speed up the speed at which you hit the golf ball. The more speed with which your club is moving when it hits the golf ball, the further it's going to go because you'll apply more kinetic energy to your golf ball. So let's do a kinetic energy problem here. Ke is equal to mass times velocity squared divided by 2. So if I did, let's say, a bullet that weighs 30 grams, it's a pretty heavy bullet, and it's traveling at 250 meters per second. I'm just making these numbers up. We have to square that, and then you divide this by 2, will tell you the kinetic energy of that. So if we take 250 times 250, 0, 0, 2 times 5 is 10, carry the 1, 5. Then you go with well, rather than do it this way, let's cross this out. 25 times 25 is 625, and then you add the 2 zeros on at the end. So you take 625 times 30 divided by 2, you're looking at over 900,000 newtons of energy. No, joules of energy. Potential energy is energy that's stored. It can be like chemical energy, it can be nuclear energy, or it could just be the object's ability to fall from a higher energy place, such as the roller coaster, or it could be from an apple in a tree like Newton had. If I have a brick that weighs 5 kilograms, and that brick is up on a shelf, and that shelf is 2 meters off the ground, GPE is equal to mass times gravity times height, 5 kilograms times 9.8 meters per second squared times the height of 2 meters. So 5 times 9.8 is 49 times 2. It's going to give you 98 newtons. All right, we'll be doing more practice problems, ladies and gentlemen. Until next time, stay good, stay safe. Catch you later.